we're on immunity now. There's two types of immunity: general immunity versus specific immunity. And really, it's kind of the difference is, I'll give you an example. When you breathe in pollen, or when you breathe in like dust, or like right now, I'm just going to touch the computer and put it on my tongue, right? I've ingested some kind of bacteria for sure. So what's going to happen is I'm going to have some phagocytes that are going to go and probably phagocytize that bacteria. Or when that bacteria gets to my stomach, the acid's going to mess it up, kill it off, and done, right? So I get a few bacteria in my mouth. I breathe in a little bit of pollen. Your body just takes care of it. It's done. When you get the flu or coronavirus, that's different. That pathogen is out to get you. It gets in your body. It starts creating an army. So when you get the flu, that gets in you by tonight, by tomorrow, you've got millions of replications of that, right? And so now they've got an army, and you need to make your army to go after their army. That's specific immunity, right? But when you make an army, you're making an army to go after one specific thing, their army. So if you get the flu, and then you turn around the next day and you get like another strain of the flu, your body has to start all over with a whole different army. You can't just go after anything, right? So just because your immune system's all ramped up doesn't mean that you can, go after a bacteria just because your body's all ramped up to go after a virus, right? But general immunity, it works for anything. It's general. So it could take out a virus, and then it could take out a bacteria, then it could take out a fungus, but not large amounts, just very small, everyday exposures. So that's kind of a practical difference between the two. They also refer to these things as innate versus adaptive immunity, because general immunity are things you're kind of born with, and adaptive immunity are things, for the most part, are things that you acquire. You get these exposures, and then you build up antibodies, or you build up some kind of immunity to it. All right, so specific immunity, general immunity, we're going to do that this lecture, and we'll do specific in another lecture. So general, there's a first line of defense and a second line of defense. And it's all about whether a pathogen gets past your epithelial tissue. So if a pathogen lands on my skin and it doesn't go any further, that's it. That's first line of defense. So my skin is an example of first line of defense. Or if something gets like on my eye, or like even in my eye, but I kind of wash it out, and my tears kind of wash it out, and then that's first line of defense. Even if I eat something and that goes into my stomach, and then the acid like inactivates it, and then I poo it out the other end, that's still considered first line of defense. We don't consider that it got into your body, because yes, I did ingest it, but it didn't actually get through my epithelial tissue. It didn't get into interstitial fluid, right? If something, like a UTI, that doesn't get in. You know what I mean? So next slide. First line of defense, your skin. We talked about that. It's a great defense. Remember, just in your epidermis, there's 5 different strata, or 4 or 5 different strata, and each of those strata have multiple layers of epithelial cells. So I didn't actually mean epidermis. I don't know why I put epidermis here for the first thing. I really mean skin, right? So your skin is an excellent first line of defense. It's an excellent protector. It's constantly shedding. Everything that you see here is dead. Right, so your skin's this is all dead cells, and they're constantly shedding. So even if something does get trapped here, it's going to shed off. Same idea with your mucous membranes, right? So the mucous membranes mean like, that like a membrane in your eye or in your nose or like right inside your mouth. Those are all mucous membranes. Those cells, which are epithelial cells, they're also shedding, right? So hair, cilia. I'll give you an example of cilia because I'm going to do it right now. I cleared my throat. The cilia, when you breathe something in, the cilia will try to trap it and push that up far enough so that you can cough it out. Hair traps different microbes. Your lacrimal apparatus, your tears, they contain something called lysozyme, which is like antibacterial. And you have similar things in your saliva. And your urine is, it has a pH that is not conducive for pathogenic growth, generally speaking. We talked about, we didn't talk about diarrhea, but diarrhea and emesis, throwing up, right? When you get food poisoning, when you eat something you shouldn't have eaten, right? Your body, oh, what's that in there? Send it back out. Is it too late? Did it get past our stomach? Send it out the other direction, right? That's your body's way of trying to get rid of pathogens that got into our body, right? Even though it's like diarrhea and throwing up and gastric juice, this is still, again, not considered second line of defense because it didn't get past our epithelial layer. Now, if a pathogen does get past your epithelial layer, that's a second line of defense. So once something moves into your interstitial fluid, into your blood, into your lymph, that's second line of defense. And now there's a few things, a few strategies that our body can take short of a full-on immune reaction, right? So we have different cells that can kind of act locally. There's some proteins, there's fever, there's inflammation. Let's go into each of them. We have two main kinds of cells that do that go after pathogens. So phagocytes or macrophages, and as the word implies, the word phago means to eat. So they eat pathogens. They kind of engulf it, take it in, and destroy it. They've got like lots of lysosomes in them, and they dissolve it once it's inside. So some of them are fixed. So like right underneath your epithelial tissue, you might have a lot of fixed pathogens, like in the malt. Some phagocytes are wandering around your body. Natural killer cells do not eat cells, but they attack them. They're kind of like the warriors, right? So they're going to go up to cells, and they have two strategies. So one's perforin. So you could think of like perforated paper, right? It's perforated. You could tear it out because it's got all those little holes in it. That's what perforin does. It punches holes in the cell, and it causes the cell to leak. So in other words, cytolysis or cytolysis. Granzymes. So there's an idea that cells have this pre-programmed lifespan built into it. And pathogens are no different. So like a bacteria will have like a pre-programmed lifespan. And then after that, it kind of does itself in. That's apoptosis, right? And so what granzymes do is when that cat leaves, they'll say, hey, bacteria, you remember how you're supposed to kill yourself one day? Well, that day's actually today. It's not later. So it induces apoptosis, which is like cell suicide, right? So remember those two chemicals, perforin and granzymes, because natural killer cells are not the only cells that use them. So when we start talking about T cells, you'll see that they also use them. So those are two types of cells, phagocytes, natural killer cells. You also have antimicrobial proteins. So interferons, you might see that in a hospital setting because they use interferons for other things like certain types of cancers or pulmonary fibrosis, things like that, because, well, they don't know why, it just works. But really, interferons are made for viruses. So the thing about virus, we talked about different types of things that infect you: viruses, bacteria, fungus, worm eggs like nematodes, and protozoa. Viruses are different. All those other pathogens attack your cell from the outside in. Exogenous. And viruses are different. They attack the cell from the inside. So we call them endogenous. So what viruses do is, viruses are not even really living things. All they are is DNA, or they could be RNA, and they have a protein coat around them. And that's pretty much what they are. And they're quite brilliant. What they do is somehow they get their DNA or RNA into you and into your cells, and then that has instructions on how to make more of them. So for example, the virus will dock up on your cell, inject its DNA into you, and that DNA will go into your DNA, and you will start making more of the viruses. And good viruses, on their way out, they surround themselves with your membrane. So you can't even tell that that you're infected, because they look, viruses, the coat around them look like your cells, so you won't attack them. And you don't know you're infected until it's too late. By the time you know you're infected, that's it, they're inside of you. Right? What interferons will do is certain cells, when they get a viral infection, they can leak out these proteins, interferons, and they're going to go to neighboring cells, and it's like a signal. Hey, it's too late for me, I got infected, but just so you know, viruses are around. And our cells could mount a defense if we only knew that there was a problem. So that's kind of what interferons do. Transferrin, a lot of proteins use iron for growth. So if you can block iron, remember, transferrin was a protein that transfers iron around, right? So you could go pick it up and take it away from bacteria and go move it around so they don't have it to grow. That's something that you find in infants. That's why it's good to breastfeed, especially in the beginning, because you're passing proteins like transferrin that can remove the iron from bacteria. And then complement, for now, just know that it enhances antibodies and enhances phagocytes. Right? You know what phagocytosis is, but we haven't discussed antibodies. That'll come in the next lecture. Inflammation. Increased permeability, meaning that you get things out of the, your filtration, increased filtration. You're getting things out of the capillaries faster. And vasodilation, so you're dilating the blood vessels so you can get blood to that area faster, right? So often when we think of inflammation, you think of like swelling. Yes, it's a reaction, and also you want to kind of trap the pathogen where it is. So that's part of the idea as well. And so there's different chemicals that that do this. And so I have them listed. I have a few of them listed here: histamines and kinins. So they're responsible for vasodilation in your vessels, and prostaglandins. They also help. They intensify kinins and histamines. And so, when that's why you're kind of all leaky, when you have an allergic reaction, you have a second line of defense going on, you have increased vasodilation and increased permeability. That's why your nose is running and your eyes are like whatever they are, right? And then we take an antihistamine. It's not just an antihistamine, but that's the word that we know. And then leukotrienes, they also increase permeability, and they act as a chemotaxis agent, which is, we'll talk about that. So that's inflammation. The fourth one, which I also have in this slide, is fever. So we have cells, antimicrobial proteins, inflammation, and then 4, fever. It's just what I wrote. Elevates your body temp. Pathogens that attack us, they like a certain temperature. That temperature is 37 degrees or 98.6, 99, whatever. Our temperature. They like our temperature. They have a certain pH that they like. It's our pH. So they don't like things that are too far away from that. So when you increase a temperature, that makes it inhospitable for microbes, bacteria, viruses to grow. So fever is not necessarily a bad thing. We tend to look at fever as being bad, and we tend to treat it. First of all, we tend to treat things like 100 degrees, even 99. We shouldn't be treating 99. You shouldn't be treating 100. Let 100 go. Especially in kids, I mean, that's what parents do. They want to, it's 100. I need to get it back to 98.6. Kids don't run 98.6, first of all. And second of all, it's 100. Let it go. They run 100 anyway, running around in the yard. So, no, that's good. Because their metabolism's getting all ramped up because they're trying to fight this infection. So, yeah, you're going to get hotter, right? And you want it to be hotter because that's going to help. That's another tool to help prevent microbes from growing. Chemotaxis, okay, I guess I have it on this slide. So chemotaxis, that's when certain cells leak proteins when they're attacked, and then those proteins are like, they attract phagocytes. So, I mean, that's really what chemotaxis is. So, certain cells that are attacked, they leak out certain cytokines or certain types of proteins, and then those are chemotaxis agents. They get the phagocytes going, and they attract them, and they draw them to the place that you want them. So that's my last slide on that. I've got one more lecture. You should be reading along in the book, though. Don't just rely on this, because I'm not covering everything, but you should be able to know 5 or 6 first lines of defense, and you should be able to explain all 4 of the second lines of defense.